to do the square root of -4, I don't know the answer. Because I don't know what is the square root of a negative number. If you put it into the calculator, it gives you an error. All right. So how to deal with that? What to do for that? So to solve that problem, there comes the idea of complex numbers. So the complex numbers, so what they did, they give the name square root of -1. We cannot find its value, but we can give it a name, just like our names. Like we all have a name. So this square root of -1 have a name. It's not its value, it's its name. It's called I, or it's read as iota. Iota. Okay. So the square root of -1 is iota. So this is what the I is. The complex numbers are represented in this form. The Z is equals to A plus B I, where A, B, they belongs to the real numbers, like their numbers 1, 2, 1.5, 2.5, anything. All right, like any number, square root 2, square root 3, it can be anything. A and B are the real numbers. Now let's look at this thing again. We know that the name of the square root of -1 is I, right? But if I do the square on both sides, both sides, the square and the square root will cancel out. So I square, iota square, is equals to -1. Okay, so so when we have the complex number here, this A is called the real part, and the B iota is called imaginary part in this one. So I squared, we got the I squared as -1. All right, so now if I again multiply the I squared, with an I squared times I, that will be equals to -1 times -1 square root. Okay. So I times I will be I cubed, and -1 times anything is just minus square root of -1, right? We don't need to write 1, which is equals to -I. So I cubed is equals to -I. All right. And again from here, if we do the square of I square here, I squared square, the red one, I'm writing with the red pen. So -1 squared. So what is the square of -1? That will be 1. And square times square will be 4. So we get I to the power of 4 is equals to 1. So I to the power 4 is 1. I squared is -1. And I cubed is -I. So these are the powers of, these are basic powers of iota. Okay, then let me just do, okay. So we can add them, we can multiply them, divide them, just like the normal. Let's say we have a complex number Z1, A plus BI, and a complex number Z2 equals to C plus DI. Right? So we want to add them. So add them, A plus BI plus C plus DI. So this I and the I terms, they will add up, and the numbers without the I, they will add up. So it will be A plus C plus BI plus DI. Let's say now we give them a numbers, A, B, C, D, any numbers. Let's say we have 2 plus 3I plus 5 plus 2I. So 2 plus 5 will be 7 plus, and then 3I plus 2I will be 5I. So that's how we just add them. And by the same rule, we can subtract them. All right, same rule, just like the same the numbers will be subtracted with the numbers, the I parts with the imaginary part will be subtracted with the imaginary part, and the real part will be subtracted with the real part. All right, similarly we can divide them and multiply them. So let's multiply them quickly. So we have number a plus bi. We want to multiply it. We want to multiply that number. We want to multiply that number with the second number, c plus. All right, we are multiplying them. So we use the FOIL rule, a times c, a times d plus I. Right? So a times c plus a d I. Right? And then we do this and that. Plus b c I and b times d I squared. And if you remember, the value for the I square is -1. All right, so we will have AC plus ADI plus BCI, and this I square is -1. So plus BD times -1. So this will become, so it will basically become, AC plus ADI plus BCI minus BD. So that's how we can multiply. Like instead of now A, B, C, D, they are representing the numbers, right? They are the dummies for any number. So like when we will have the numbers, actual numbers, we will just multiply the actual numbers instead of these. Like these will be replaced with the numbers. And there's another thing. If we have, let's say 2 over I, we cannot have this I in the denominator. We do not leave the I in the denominator. So we have to get rid of that from the denominator. So to do that, what you do sometimes, like you just multiply it with its, okay, so it's just like rationalization. It's just like the rationalizing the square root. Like if we do not want the square root inside in the fraction down there, the way we rationalize it, it's the same thing, right? So let's say I have a question here, 5 plus I square root 3 over 1 minus I square root 3. Okay, so now there's a problem. This I is in the denominator and we do not want it there. So to get rid of that, what you do, you multiply it with its conjugate. So z, it's z, the number, its conjugate is, let's say we have the z, it's written like this, it's z conjugate. So we had the z is the number, complex number, a plus bi. So its conjugate, the z, is actually equals to a minus bi. The I term, you flip the sign of the I term. It was plus, you made it minus. So that's the conjugate. So what we do when we want to rationalize it, when we want to get rid of it from the denominator, we multiply it with its conjugate. So let's do that. So z, so we don't need to write the z anymore. So let's just do it. So it will be equals to 5 plus I square root 3 over 1 minus I square root 3. We multiply it with its conjugate, which will be 1 plus I square root 3. But since we know the rule, we cannot just do it on one way. Like we are not allowed to multiply anything by ourselves. So to balance it, we also need to multiply it on the numerator, because you see, we can still cancel them out. Like this one and this one can cancel them out and they are still 1. So we did not did any change in the question. So now let's multiply them. Okay, so we will apply the FOIL rule that we just learned for multiplication. So 1 times 5 will give us 5. Then 5 times I square root 3, so it will be I 5 square root 3. Now I square root 3 times 1, that will be 1. So I square root 3 and I square root 3 times this. That will give us I times I will give us I squared. And the square root 3 times the square root 3 will just give us 3. Now we multiply the lower ones. I times I, 1 times 1 is 1. Then 1 times plus I square root 3. And then minus 1 minus I square root 3 times 1 will be minus I square root 3. And then we multiply this times this. That will minus plus times minus is minus I squared. Square root 3 times square root 3 will be just 3. So now let's combine the like terms, as I said. So this is 5, it's a number, but the I terms, we will see if we can add them, right? So this is 1 and this is, so we have I square root 3 and this is 5I square root 3. So that will add up to 6. 5 plus 1 will be 6I square root 3 because they are the like terms. And I square is minus 1. So that will be minus 1 times 3. Okay. And now you see this one is with minus and this one is with plus. They can cancel out. And I square is actually minus 1. So we will have 1 minus 1 times 3. Okay, let me just write it the final step here in this. I'm just writing the final step here. Yes, I can repeat that. Okay, so what we did here, this was 5. This is a number, and I square root 5I square root 3. This is different thing. This is with the imaginary item I. So we cannot add this with the 5, but I square root 3 and 5I square root 3, they are like terms. They are same terms. So we can add them. So it will be 5 plus 1 will be 6. 6I square root 3. And then I square, its value is minus 1. So it becomes minus, like it becomes minus 1, right? Here it is. Minus 1, or you can just leave it as minus. It's the same thing. So minus 1 times 3 or just minus times 3, that's the same thing. And then in the lower one, this is plus I square root 3 and minus I square root 3. So they cancel out. So I get 1 minus I square and then times 3. And the value of I square is minus 1. So that's how I got the minus 1 here times 3. Now we just simplify it further, one more step. So 5, and this is minus 3 actually now. Minus 1 times 3 is just minus 3. So 5 minus 3 will be 2 plus, we can write it 6I square root 3. And this one minus times minus will become plus, right? Minus times minus is plus.
Excuse me, teacher, can you repeat that? Because a student, Stefan, have a question about that.
Yes, yes. Okay, so let me write it for you again. What we did, we want to get rid of this square root. We want to get rid of the square of this I from the denominator. We do not want it in the denominator, right? So to get rid of that, we need to multiply it with its conjugates. This is the z conjugate. If we have a number, z, complex number, we want to find its conjugate, we change the sign of the imaginary part, right? So I had 1 minus I square root 3. So I multiplied it with 1 plus I square root 3 by flipping the sign with its conjugate. But since we cannot just multiply the denominator, we also multiplied the numerator. Then we applied the FOIL rule for the multiplication. First we 5 times 1 and 5 times this thing, right? Then I square root 3 times 1 and I square root 3 times I square root 3. Then in the bottom part, I did 1 times 1, which is 1, and 1 times minus I square root 3, or plus I square root 3, right there. And then minus this times this, and this times this. Then in the next step, I combine the like terms. I 5 square root 3 and I 1 square root 3, they are same I terms, imaginary terms. You can add them. So 1 plus 5 is 6. Then I square, the value of I square is minus 1. So we replace the I, we put that minus 1 times 3. So 5 now. So now in the denominator, 1, this one is with the plus, this one is with the minus. So they cancel out. And again, I square is minus 1. So we got minus 1 here. So then we just minus times minus is plus, which is 4. And then the above 5, this is minus 3. 5 minus 3 is 2. 2 plus 6I square root 3 over 4. That's the final answer. After, you can say we was dividing these two, we was dividing the two complex numbers. So we divide them this way. We get rid of the I term from the denominator. Okay, all right. Okay, all right. Let's just quickly have a look at now in the remaining time on trigonometry. Okay, so we have trigonometry. Yeah. So trigonometry word comes from the trig means the triangle. Actually trigonometry. So it was actually the measurements of the triangle. That what it was literally mean when it was discovered. So trigonometry is like it's where we study the triangle.